So Jackie's training for a cycle race. She reads a cycling blog. It says cyclists should aim to keep their heart rate above 72% of their maximum heart rate. Jackie uses this formula to work out her maximum heart rate, where M is a maximum heart rate in beats per minute and A is age in years old. Jackie's 25 years old, so we know how old she is, so we can work out what her maximum heart rate is. Now we've got a scatter diagram. Scatter diagram shows a relationship between power in watts and heart rate. Okay, so we've got heart rate there, beats per minute, and we can connect that to the formula because we're going to work out her beats per minute. And we've got the power that she's producing. So to produce 100 watts of power, a cyclist uses about 350 kilocalories per hour. Estimate the number of kilocalories Jackie uses per hour if she cycles at 72% of her maximum heart rate. Crumbs. This is a 6-mark question, so I can spend 12 minutes on this. Now, rather than just thinking, oh my goodness, lots of words, there's lots of different strategies I'm having to use here, crumbs, I just won't even attempt this question. No, I'm going to just calm myself down, take it step by step. Let's highlight some of the key information to start with. So 72% of their maximum heart rate, that's something that's key. And Lacey, yes, it says 72% of her maximum heart rate. So whatever her maximum heart rate is, we need to find 72% of it. There's this formula, and I need to use that. And we know that she's 25. We've got this scatter diagram, so we're probably going to have to use that, but let's take it step by step. The question actually says, estimate the number of kilocalories Jackie uses per hour if she cycles 72% of her maximum heart rate. So maximum heart rate, that sounds, here we've got to produce 100 watts of power. They use 350 calories per hour. So if we take this step by step, the first step I'm going to do is calculate her maximum heart rate. So I can use a calculator, and it's simply a case of using the formula. And that way, even if that's all I do is put the number into this formula, then I will probably get at least one of those marks. So 191.5 take away, and it's 0.007 a squared. A is 25, so it's 25 times 25. So I'm going to put brackets around this. That's 0.007, just to remind myself of the order of which to do things, times. My calculator doesn't have a squared button on it, so to do squared, I'm just going to do times 25. Now, what I do know is with multiplication, it doesn't really matter what order you do things. So I'm going to enter into my calculator. Before I write anything down, I'm going to go 25 times 25. So 25 squared is 625. I need to multiply that by 0.007 times 7. Okay, and it gives me the answer 4.375. Now I've got to be really careful because it's very easy to make a calculator error. And so if I just write down the steps that I have done, it means that I can get the marks even if I make a mistake. 4.375. I won't get all of the marks, but I can get some of the marks. Okay, so now I just need to clear my calculator and do 191.5 take away 4.375. That gives me 187.125. 187.125. 187.125. Right, I found her maximum heart rate. Brilliant. Step 1 done. what do I need to do next? Estimate the number of kilocalories. She cycled at 72% of her maximum heart rate. So I want to find 72% of this number. No wonder it's got so many marks. There's a lot of things to do. Now, there's lots of ways to find 72% of something. Whatever your preferred way is will be fine. My preferred way is to divide by 100, then multiply by 72. So that would be I'm going to write it here, 187.125 divided by 100, and then times by 72. So I've got the figure in my calculator already. I'm going to divide that by 100 because that gives me what 1% is worth. That's 1.87125. I'm going to multiply that by 72, and that gives me 134.73. So 134.73. Okay, so that is Jackie's heart rate, 72% of Jackie's heart rate. So that's how she's cycling. What do I do with that? I want to work out how many watts of power. How do I work out watts of power? Right, okay, now that's when my graph comes in. So the heart rate is 134.73, so that's nearly 135. So my graph will go up in even intervals. So if I've got 120, that means that's 130. Now we've got 140. Now I need to read across. Now what's going to help me is doing a line of best fit. So let me draw a line of best fit. Which sort of, so it'll be a line that kind of goes roughly through all of the points. And obviously it is an estimate, so I would expect that in the mark scheme it will be sort of answers within a range, because it's going to be very difficult to get it accurate. So we want to go across from 135, let's say. So it's quite hard to read, around there. So there's 130, and 135 is going to be about here. So that's 170 watts. So I'll write that in, 170 watts. So we've got a lot of the way through this question here, but we still haven't got a final answer. We need to estimate the number of kilocalories. So we've got the watts, and then we've got it, the watts of power uses. So this actually, I'm going to write this. If we know that 100 watts gives 350 calories, and I need to find it for 170, what I'm going to work out is I'm going to divide both sides by 100, sorry, so that it gives me 1. Because if I can work out how many kilocalories 1 watt produces or uses, then that will tell me. I can then work out what 170 is. So 100 divided by 100 is 1. 350 divided by 100 is 3.5. So it's 1 to 3.5. So now I need to do 170 times 3.5 to give me the number of kilocalories. Okay, 170 times 3.5 equals 595. 595. So that's what I'm going to put as my answer. Does that answer make sense? I'll just check it once I've written it in. 595. So 100 watts power is about 350 calories per hour. And she's going like almost double that. and so it is almost double the kilocalories per hour. So that answer looks sensible. I've done all my steps. I've shown my working. I'm happy with that as my answer, and I'm pretty confident that I should have got 6 marks there.